air standard power cycles. In the previous chapter, we considered idealized four-process cycle, including both steady-state process and piston cylinder boundary moving work. The question of phase change cycle and single-phase cycle was also mentioned. We then examined the Rankine power plant cycle in detail, the idealized model of the phase change power cycle. However, many work-producing devices utilize a working fluid that is always a gas. The spark ignition automotive engine is a familiar example, as are the diesel engine and the conventional gas turbine. It be for a gas working fluid. For example, spark engine, spark ignition automotive engine, or diesel engine, and the conventional automotive gas turbines. Conventional in all these engines, there is a change in the composition of working fluid, because during combustion it changed from air and fuel to combustion products. For this reason, these engines are called internal combustion engines. In contrast, the steam power plant may be called an external combustion engine. An steam power plant external combustion engine. Because heat is transferred from the products of combustion to the working fluid. Because heat is transferred from the products of combustion to the working fluid. External combustion engine using a gaseous working fluid, usually air. A gaseous working fluid, usually air, to date they have had only limited applications, but use of gas turbine cycle in conjunction with a nuclear reactor have been investigated extensively. There is limited application, but gas turbine cycle conjunction with nuclear reactor has been investigated extensively. Other external combustion engines are currently receiving serious attention in an effort to combat air pollution, because the working fluid does not go through a complete thermodynamic cycle in the external combustion engines. Working fluid does not go through a complete thermodynamic cycle in the engine. The internal combustion engine operates on the so-called open cycle. For analyzing internal combustion engines, it is advantageous to advise closed cycle that closely approximates the open cycle. So, for example, the internal combustion engines have open cycles. However, analyzing open cycles to devise closed cycles that closely approximate the open cycle. Which is based on the following assumption. A fixed mass of air is the working flow throughout the entire cycle. Throughout and the air is always an ideal gas. Thus there is no inlet process or exhaust process. The combustion process is replaced by a process by a process transferring heat from an external source. The cycle is completed by heat transfer to surrounding. Heat transfer to surrounding in contrast to exhaust and intake process of an actual gas. Intake process of an actual engine. All processes are internally reversible. An additional assumption is often made that air has a constant specific heat. Evaluated at called cold air properties. Recognizing that this is not the most the principal value of the air standard cycle is to enable us a standard cycle enable us to examine qualitatively the influence of a number of variables on performance. The quantitative results obtained from the air standard cycle quantitative results obtained from the air standard cycle. And the mean effective pressure. Mean effective pressure will differ from those of actual engine. Our emphasis, therefore, in our consideration of air standard cycle will be primarily on the qualitative aspects. The term means effective pressure which is used in conjunction with the reciprocating engine is defined as the pressure that if it acts on the piston during engine power stroke. would do an amount of work equal to that actually done on the piston. And the amount of work equal to that actually done on piston. The work for one cycle is found by multiplying this mean effective pressure by the area of the piston multiply to area piston for one cycle. And by the structure. The next section is the Brighton cycle.